Hello. This is a demonstration of Riverbed acceleration in action. We'll start with a short overview of the scenario in our lab. Here we can see we've a single branch with two devices. N21PC is where we are, and we also have a host joined to the domain N21, Win10. They're connected to a data center with a simulated wide area network of 1.5 megabits per second and with a round trip time of 70 milliseconds, with SteelHeads deployed in path at each end. The traffic that we'll be using is Server Message Block version 3 for file sharing, which is decrypted by the SteelHead's Active Directory integration. Before we accelerate this connection, we'll benchmark the performance while we have no optimization. I'll move to our client machine using remote desktop and map a network drive in the normal way. Let's take a high-resolution image of around 3 megabytes and time our download. Without optimization, it takes 20 seconds to transfer. Now to enable our acceleration. We'll be going through the details of navigating the user interface later in the course, but for now I'll enable our service by disabling a pass-through rule. Connecting the drive again, we can see the status of the connection on the current connections report. The table shows our connection successfully optimized with some extra detail, including the padlock icon, showing that the connection is re-encrypted between the SteelHeads, as is best practice. We can also see the variant of SMB in use, along with the Active Directory ID of the user. Opening up the connection shows more details of the path of the connection. We've no data reduction as yet, as there's been very little traffic so far. Now to run our first pass of the data. This we know as the cold pass, where both SteelHeads are learning the patterns of data and populating the data store with them. The cold pass probably will not reduce the data at all, but is still likely to be quicker because the SMB protocol is streamlined by the SteelHeads. Our cold pass was nearly twice as fast, at 11 seconds. Now to try again with a warm pass. 1 second. So 20 seconds down to 1 second. Keep in mind that in this scenario, we have only one user. In a production environment, all users at the branch will benefit from the stored data as the SteelHeads learn the patterns. Now let's look at the actual traffic. There was a TCP dump running on both the local side and the wide area side of the branch SteelHead. We can download them and use Packet Analyzer to interpret what happened. Here we see our benchmark, our cold and warm passes. Note the throughput of the warm one, which is way in excess of the capacity of our link. Looking at the corresponding wide area side, the warm pass barely even registers, as there was only a few references sent, pointing to the byte patterns in the data store. Real networks and their increase in performance depends upon many factors, but as we see here, one of the most commonly used protocols benefits enormously from Riverbed acceleration. Thanks for watching.